Jack and Tom have asked me to make a video on finding the fifth roots of -11. So, first of all we'll type number, then root. The 5 roots of -11 are all on a circle, so we'll find the radius, which is equal to the power of, and we'll take the absolute value of the number to the power of, and then we'll say that r is equal to, we'll use a conditional expression here based on whether the number is positive or negative. So we'll say if the original number is less than 0, then we'll use minus the radius, otherwise we'll use the radius. Now we're going to create a table. The first value of n is going to be 0, and this is going to equal cos of 2 times n times pi divided by the root. And because I'm going to use this several times, I'm going to put $1 in front of the 4. Then we're going to copy that into the next cell, but then change that into a sign, and then this cell is going to equal the radius times the cosine, and we need $1 in front of the 6, and this cell is going to be the radius times the sine, and we need $1 in front of 6. Now this cell is going to equal the previous cell plus 1. I need to copy these cells down 1, and then I can copy all of these. Next we'll draw a graph of the table, and here's our graph of the roots. This is the root for n equals 0, n equals 1, n equals 2, n equals 3, and n equals 4. If we wanted to find the fifth roots of 11, we can now change -11 to 11, and now we get these roots. So when n equals 0, the root is real. When n equals 1, the root is complex, which is this value here. When n equals 2, this is the root. When n equals 3, and when n equals 4. Not only that, we could find the fourth root. We could have the fourth root of -12, say, or we could have the third root, and if the root was +12, then we would see that there's the root. So we've now created a way of calculating the roots of a range of numbers. So getting back to the original question, we want the fifth roots of -11.